Welcome back to the revision class. This time we are going to revise the series parallel combination of the resistors. So first of all, discuss the series combination of the resistance. In series combination, suppose we have two resistances R1 and R2, and both are connected such that tail of the first resistor is connected with the head of the second resistor, right now, and head of the first resistor is connected with the cell and tail of the second resistor is connected with the negative terminal of the cell, and there is a switch here for the on and off the circuitry, and the voltage of the cell is given V. If we have 2 voltmeter which is used to measure the voltage across these two resistances, we have the 2 voltmeters V1 and V2 that is used to measure the voltage across these two resistances, right now. And because there is a single wire is here, this circuit has a single wire, that is why the same amount of the current flows through both the resistances. Let us assume the value of the current flows through both the resistances is I. So in the series combination, the same amount of the current flows through the circuit. So in the series combination, if you see that the applied voltage is equal to the algebraic sum of these two voltages, which is the individual voltages across the load, right now. So in series combination, the external voltage applied is equals to the sum of the individual losses of the across the resistances. So V is equal to V1 plus V2, right now. And it's simple, the law of conservation of energy. Whatever energy you have in the cell, that energy utilizes in both the resistances. So the total energy is equal to the energy utilizes by the first resistor and the second resistor. So it is basically this formula is coming basically from the law of conservation of energy, right now, because you know that the potential is a amount of work done, and you know the work energy theorem is related. So here this relation is basically the law of conservation of energy. So V is equal to V1 plus V2, and you can write the V is equal to V1. What is V1? V1 is the voltage across the resistance R1, right? So we can write according to Ohm's law, V is equal to IR. So we can write V1 is equal to I into R1, right? Because we know that V is equal to I into R, and the current flowing through this resistor is I, because we have a single wire. One wire has only one current. So V1 is equal to I into R1. Similarly, for the V2, that means voltage across the second resistor, you can write I into R2. Right now? I into R2. So here the I is common, take the I common. So V is equal to I in the bracket R1 plus R2. Or you can write V by I is equal to R1 plus R2. Of what is V by I? V is the total voltage, right now. And what is the I? So I is the total current. So this summation is total voltage upon the total current. So that means the total voltage upon total current is equivalent to total resistance. So in place of V by I, we can write the total resistance offered by the circuit. So this V by I is equal to the R total or the R net. So R net is equal to R1 plus R2. Right? So you can see here the total resistance offered in the series combination is equal to the sum of the individual resistance. So the total resistance R net is equal to R1 plus R2. Right? Let us discuss some numerical. So in this question, we have the two resistances 2 ohm and 3 ohm, which is connected in the series combination. You can see that the tail of the first resistance is connected with the head of the second one, and the head of the first resistance is connected with the supply, and tail of the second resistance is connected with the supply. Right now, it is an example of the series combination. And our aim is to find what is the amount of current flowing in the circuit. What is the amount of the current flowing through the circuit? So if our aim is to find the what is the total current flowing in the circuit, we have to find the what is the total resistance. So we know that the total resistance, we can find the total resistance of the circuit. So what is the total resistance? Yeah, R net. So R net is equal to R1 plus R2. So here 2 ohm plus 3 ohm. That means it is 5 ohm. That means this circuit is equivalent to this circuit, right now, where in place of these two resistances you can use only one resistance of the magnitude, which is R1 plus R2. So here the R net is 5 ohm. So R net is given here 5 ohm. Now we simply apply the Ohm's law. Ohm's law is what? V is equal to I into R. So here our aim is to find the value of the current. So I is equal to V upon R net. So V is 10 volt and the value of R net is 5. So you will get the value of the total current is 2 ampere. You will get the 2 ampere. So in the series combination, you should find the first, what is the total resistance offered by the circuit. So here that is equals to R net is equal to R1 plus R2, and the value of the R1, R2 is given 2 ohm and 3 ohm. So simply you can find the 2 ohm plus 3 ohm, which is 5 ohm, and then after applying the Ohm's law, you will get the what is the total current flowing in the circuit, which is how much? 2 ampere. Clear? Now let us discuss the parallel combination of the resistances. So in the parallel combination of the resistances, we should connect the resistances such that both the head of the resistances R1 and R2 is connected at one point and tails of the resistances connected at the second point. And these two junctions should be connected with the supply. This is, I am using a key, and this is the applied voltage is V. So this kind of arrangement, when the head of the two resistances, two or more resistances connected at one point, and tail of two or more resistors connected at another point, and these two junction points are connected directly with the supply voltage, then this kind of arrangement is called the parallel combination. And you can see that both the resistances are connected across the same voltage source. That is why this time the potential across the load is constant, right? But the current flowing is starting from the positive terminal of the supply. So from I is connecting here. Now you can see here this I has two paths, one this wire, one this wire. So across these two wires, the current will divide, right? So suppose in this R, the I1 current is flowing, and this R is I2 current is flowing. So this I is totally divided into two branches, I1 and I2. I1 flows in the R1, I2 flows in the R2. And again, all the current will combine here, and the total current will reach to the cell is I. So here the law of conservation of charge is valid. Whatever amount is leaving the cell, the same amount of the reaching the cell. So this kind of arrangement is the parallel combination. So here you can see that at this junction, I is divided into I1 and I2. So according to law of conservation of charge, we can write, so I is equal to I1 plus I2, right now, because this I is divided into these two. So the total of this I1, I2 is equal to the I. So I is equal to I1 plus I2 or I1. I1 is what? I1 is the current flowing through this resistance R1. So according to Ohm's law, V is equal to I into R, or I is equal to V upon R. So if our aim is to express I1 in terms of V and R, so we need the potential across the resistance and the value of the resistance. So here we can write the I1 is how much? V. So what is the potential across the load? Because both are in the parallel combination, the potential is constant. So the potential is V, because the load is connected directly to the cell. In the parallel combination, potential across the resistances is constant, which is equal to the applied voltage V, and divided by the value of the resistance. So here the value of the resistance is R1. So I1 can be expressed V upon R1. Similarly, for I2, you can write from this formula Voltage again constant, because both in the parallel combination potential across the resistances is constant. V upon, and this time R2, right? Take V common, so I is equal to V common in the bracket 1 upon R1 plus 1 upon R2, right now? And we can write here 1 upon V by I is equal to, we already have taken this side, 1 upon R1 plus 1 upon R2. Right now? Again, if you simplify this one, so I will go in the numerator, that will become I by V and I by V. So I am simply rearranging this one. I am writing here 1 upon V by I. And V by I is what? V by I is equal to become R. From this cross multiplication, you will get V by I is equal to R. So in the denominator, V by I, you can write the R. And V is what? V is the total voltage, and what is the I? I is the total current. So in place of V by I, if you are writing the resistance, so this is the total resistance. So 1 upon R net is equal to 1 upon R1 plus 1 upon R2. Clear? So in the parallel combination, you can find the total resistance or the net resistance by the formula 1 upon R net is equal to 1 upon R1 plus 1 upon R2. Right now? So let us discuss few numerical on the parallel combination. So in this question, two resistances of 10 ohm and 10 ohm are connected parallelly across with the 10 volt source, and our aim is to find what is the value of the current supplied by this source. Right now, that means our aim is to find what is the total current. Total current I is entering from the or linked from this flowing in the circuit. Okay? Total current flowing through this circuit. So how can find? First of all, we have to find the total resistance offered by the circuit, because once you find the total resistance, that circuit becomes a simple circuit. Right now? So because it is a parallel combination, so we have to find the R net, which is the total resistance. So what we have the formula? So 1 upon R net is equal to 1 upon R1 plus 1 upon R2. Right now? So 1 upon R net. Our aim is to find the R net is equal to 1 upon R. See, sometimes to apply this kind of formula, it is sometimes students are making the mistake. In place of 1 by R net, they are writing R net is equal to 1 upon R1 plus 1 by R2. So you should prefer to memorize the formula like this one. R net is equal to R1 R2 upon R1 plus R2. Right now? So you should prefer to memorize the formula like this one. Right now, both are same thing. After taking the LCM and cross multiplication, you will get the same. R net is equal to R1 into R2 upon R1 plus R2. Right now? And just put the values of R1 R2. So you will get R net is equal to R1 R2, yani 10 into 10 divided by 10 plus 10. Right now? So after simplification, you will get 5 ohm. Right now? Because it is 100 and divided by 20, so you will get the 5 times. So 25 is 100, you will get the 5 ohm. So in place of these two, you can use only one resistance of R net. So that circuit becomes simple circuit. So this is the 10 volt circuit, 10 volt supply, and R net is equals to 5 ohm. And our aim is to find the value of the current I. Right? So again, just apply the Ohm's law. I is equal to V by R net. The value of the V is 10 and the value of the R net is 5 ohm. So what you will get the value of I? So you will get the value of I is 2 ampere. So you will get the value of the current flowing in this circuit is 2 ampere. So this time the voltage source or the energy source will supply the current of net. I think with the help of these two numerical, one is from series combination, one is from parallel combination. So first you have to find the R net, and after that becomes a simple circuit. And after that you just apply the Ohm's law, V is equal to IR, and whether you can find anything, whether you can find the resistance, whether you can find the voltage, whether you can find the I, according to the question, just put the values and just find the required term. So I hope you understand the series parallel combination of the resistance. And if you have any doubt, you should mention in the comment section. Thank you.